Okay, so my demo tonight is to show you guys how I make the stuff I make, because I think it's pretty to look at, but it doesn't really make sense how I get to these things. So I brought one piece that's in progress, and I brought these other variations on it, and on the idea. But I want to start from the very beginning, which is text, which is how I got the idea to do these things in the first place. And so I look at data, and in the case of these little round ones that I do, I call these 8-bit classics, and they're from classic literature. And I was interested in, and still am interested in, how something can be completely readable and completely not understandable at all, not readable. You can read it, you can decipher it, but there's no meaning in it. I can't read it like I can read words on a page. So this particular one is Canterbury Tales, and I've done about 20 or 30 of these so far. They take about a week or so to get done. And I start with a little bit of text, and you can see there's not a lot of text, maybe 400 characters, and this includes spaces and punctuation, everything. And these letters in a computer are assigned what's called an ASCII value. So when you type a capital A or a little a, it gets assigned a particular value, and the computer knows to spit a big A or a little a out, or a space, or whatever it does. So what they have, and so you don't have to remember all these things, is a thing called an ASCII lookup table. And it has all of the characters, the capitals and the lowercase, and it has numbers assigned to it, decimal values, whole numbers, right? So they start off with like this, like a space is assigned number 32, and a capital is assigned number 65. So a lowercase a is 97. So what I do then is I look at those numbers, like say for the space, which is a 32, I break it down into binary, into 8-bit binary, and then I plot the string of ones and zeros that I get from that translation onto these papers. Clearly. Alright, I still got it. Okay.
Oh, I missed out. Nope, I got it. I missed out on your introduction. Got it, and it was gone. Is anybody lost? Yeah.
So let's talk about, let me show you how this works. So we've got a space. Yeah, sure, yeah. So we've got this space.
So is this your art? Which is the art?
This is the art.
This is the art. And this is the art.
This is the art in progress.
Is that the art?
This is the art.
Is that the art?
That's the art.
Oh, wow.
It's all the art.
This is all the art.
It's all the art.
It comes from this.
Yes.
Wow.
It goes from this. Yes.
Oh, okay.
Okay, so if I have a space, and that's assigned an ASCII value of 32, I'm going to write that down, 32, right? How do I get from that 32 to these, to this? So in 8-bit binary, we've got all these spaces. Think of it as 8 spaces. 5, let's see, 1, 2, 4, 3. And the computer assigns these values power of 2, right? So the computer only knows on or off, 1 or 0. It either has electricity or it doesn't. It can't see the shades of gray. So everything is broken down into just black and white terms. So this is, if you're thinking powers of 2, so this is 2 to 0, this is a 1, this is 2 to the first, that's a 2, 2 to the third, that's a 4, right, on and on. So that you've got 8, 16, 32, 64, and 128. Right? These are all powers of 2. So you can see the space is a 32, right? And there it is, right there, right? So for 32, I'm going to have a 0, 0, 1, which is here because I want that. 0, 0, 0, 0, 0. Right? There's my 32 in binary, an 8-bit binary. That's a 32. Okay, so now if you look back on one of these, it's really easy to see. When there's a space, you'll see it, like right here, there's a space here, there's a 32. I've written down the number, the value, it's a 32. And these are the powers of 2 coming up. And here, this is actually 7-bit binary here, but still, this is the space for the 32 right here.
Okay.
So I've marked the 32.
And does that correspond to the old punch tapes that read?
Yeah, like punch cards. Yes, like punch cards. Yes.
Can you use this to spy? Like you can send secrets and you can make messages and code?
I guess if there was somebody that didn't know how to read this, but
I don't know how to read it.
but there's an ASCII lookup table. Anybody can figure it out.
That table. What's the name of that book?
Introduction to Computing Systems.
I do not think that I will take that from the restaurant. But you sure do know it. I gotta edit. That's
So on these, every group of 8 is one letter or one space or a character of some kind. And you'll see others on the wall that I've done. And I'd gotten this idea from taking a computer science course where we had to create a program that spit out ones and zeros when you type something in. And so I named all my variables according to Moby Dick, the characters of Moby Dick. And of course the kids next to me did not get this. And that's when I went home and I said, now I know what to do with these papers that I've got sitting on the shelf. I translated all this classic literature into binary and put it on there because they didn't read it anyway. They still don't know what it means, but there it is.
So what do these paintings behind you mean, like the 24027?
This is the First Amendment, and this is the Second Amendment.
Oh, wow.
And that is, if you were to add up the values of all the letters and the spaces and punctuation in the amendment, that's the number you get. So it has a real value.
Real value.
Yeah.
So if someone purchases your work, do you have the explanation for that particular?
I have a lot of these kinds of things, these papers.
No, but what if someone needed to know how that number came about? You would do that.
Yeah,
I mean, you would do
I could
it.
explain it.
Because you just did.
I could
Just
do it.
talking and yes. Yeah.
This one here
People
is
would love
sound.
that.
You can translate anything into binary. Anything you can send over a computer can be translated into binary. So this is a sound. This is Neil Armstrong landing on the moon and saying one small step for man. So here it is in binary.
Now that look, is this just in a different shape?
Yes.
It's the same language.
Yes.
And can you read it without knowing what you've written? If you were to look at it without understanding, are you that familiar with it that you can read
Me personally, no. I can pick out an old value.
Got it. Got it.
32.
Got it. Got
I always remember that one. That's
Okay.
it though. Yeah.
it. So it doesn't become automatic.
No, it doesn't. No. But on these, I do like, I add up everything. I'm a little, what do we call that? Compulsive. Compulsive
Check it
is
to
the
make
word.
sure it
I
is.
add everything up. And so like on Big Bang Theory, this one was kind of, these are kind of a joke, I think. So on Big Bang Theory, this one is Genesis and Darwin and John Locke's letter for the separation of church and state. And I added it all up, and John Locke wins the argument in this one, which I think that's funny.
I think that's
Yeah.